Hello everyone, I hope you are doing well. So in today's video, I'm actually going to go through the 2019 Northern Hemisphere exam 1 for the 2019 year. So yeah, let's do this exam. Let's have a go through it. Okay, question 1. Let y equal this. Find dy dx. Okay, so this straight away is a quotient rule. So that's u, that's v. So we can say dy dx is v u dash minus u v dash all over v squared. So what we're going to say in this case is our v is ex, our u dash is 4e2x minus your u, which is your 2e2x minus 1, and your v dash is just ex all over ex squared, e2x. Okay, what we can do is we can see if we expand this, it'll be 4e 3x minus ex 2e 2x minus 1 all over e 2x. Okay, so I'm just going to move this up, make a little, okay, here. So we can say that e3x minus 2e3x plus ex all over e2x. This simplifies to 2e3x plus ex all over e2x. I mean, you can take a common factor of ex, so let's try to do that. So let's bring it over here. And we can say, take a common factor of ex. That will be 2e2x plus 1 all over e2x, which is 2e2x plus 1 all over ex. Alright, so I'm just going to write you the final answer. Okay, I'm just going to put the final answer over here. So dy dx is 2e2x plus 1 all over ex. Okay, next question. Let f of x equal this. Find f dash of it when it's pi on 3. Okay, so f dash of x is what? So that's your u and that's v, so we're going to use the product rule. So it will be x squared minus 3 sine 3x. Is that right? So, yep. Plus cos 3x times 2x. Yep. And so, I mean, you don't need to simplify it because, okay, let's just simplify actually, yeah. So, negative 3x squared sine 3x plus 2x cos 3x. Okay, and what we're going to do now is f dash pi on 3 is negative 3 pi squared over 9 sine, so pi on 3 is just putting a pi over here, plus 2 pi on 3 cos pi. So this will be negative pi squared all on 3 sine pi. Okay, so if I'm drawing the sine graph at pi over here, it's 0. So we can say this bit gets multiplied by 0 plus 2 pi on 3. What about cosine? Well, cosine goes like this, so, and it's at negative 1. Negative 1. Negative 2 pi on 3 is your final answer. Okay, next question. Find f of x given that f of 1 is this, so, and f dash of x. Okay, so what we're going to do is we're going to, for f of x, we're going to integrate 2x squared minus 1 over 4 x negative 2 on 3 with respect of dx. Doing that, we know that f of x, well, the first one is 2x 3 divided by 3 minus 1 over 4. Okay, so x negative 2 on 3. If we add 1, it will be 1 on 3, and we divide it by 1 over 3, it will be 3. And multiplying that by negative 1 over 4, you get 3x 1 on 3 all over 4. So now, just let me rub this one over here and put that over here. Negative 3 over 4 x 1 on 3. Dx plus c. Is that right? Have I made a mistake? So plus 1. Okay, looks right. Let me just rub this all off. Now, given that f1 is equal to negative 7 over 4, we can sub in 1, so it'll be negative 7 over 4, 2 on 3, minus 3 over 4 plus c. Would be negative 7 over 4 plus 3 on 4 minus 2 on 3 equals c. So it'll be negative 1, negative 2 on 3 equals c, which in this case will be negative 5 over 3 equals c. So your final answer for f of x is 2x over 3 minus 3 over 4 x 1 on 3, and c is negative 5 on 3. That's your answer. Question 3, evaluate this and that. Okay, so this is not too bad. So we know that 2 to 7 of 1 over x plus root 3, the first one, dx is what? Well, we know that it will be it'll be the integral of log e, absolute value. But here we don't deal with absolute value because it's methods, so we're just going to put these in the round brackets. X plus root 3 from 7 to 2. Simplifying that, so we're saying log e, 7 plus root 3 minus log e, 2 plus root 3. This simplifies to log e, 7 plus root 3 all over 2 plus root 3. For the next one, we're saying 2 to 7, 1x minus root 3 dx. Okay, same thing. So it'll be log e, x minus root 3 from 7 to 2, log e, 7 minus root 3 minus log e, 2 minus root 3. The final answer is log e, 7 minus root 3 all over 2 minus root 3. And yeah, those are your evaluated answers for both of them. Show that half of this equals that. So, easy. So let's say left-hand side. So keep the half outside. And if we multiply both top, so if we cross-multiply these and multiply these together, we should get this over here. So let's do that. So it'll be x plus root 3 plus x minus root 3 all over x minus root 3 x plus root 3. Okay. This here, keep the half outside, it'll be 2x all over x squared minus 3. So it'll be x all over x squared minus 3, which is equal to your right-hand side. Yep, perfect. Use your answer to part A, this one, and part B to evaluate this in the form of this, where A and B are positive integers, 1 mark. Okay. Well, because we know this inside is equal to this, let's do that. So we're saying we're saying that from 2 to 7, and let's take the half outside of 1 over x minus root 3 plus 1 over x plus root 3 dx. Expanding those, so it'll be 2 to 7, 1 over x minus root 3, let's put a bracket over here, plus 2 to 7 of 1x plus root 3 dx. Close bracket, and we know that we already calculated those, so putting those together, we're saying half 1x, so the first one's x minus root 3, which we said was 7 minus root 3, so it'll be log e 7 minus root 3 over 2 minus root 3 plus log e, the other one was 7 plus root 3, so 7 plus root 3 all over 2 plus root 3, was it? Yep. So doing this by log laws, we know it'll be half, they'll be multiplied, so it'll be log e. So the tops will be multiplied, so it'll be, again, and it is a difference is perfect square, so we can just say, so 7 times 7 is 49, minus 3 over, even the bottom's differences of perfect square, so it'll be 2 times 2, so it'll be 4, minus 3, equals half log e 49 minus 3 is 46 over 1, so which is just 46, which is just 46, 46, and is that it? That's, it says where a and b are positive integers, 1 over a, yep, 2, looks right, yeah. Question for a function g has a rule g of x, this, state the maximal domain of g and the range of d over its maximal domain. Okay, nice. It's a log function. Now we know log, to get the actual domain, your maximal domain, it's the inside function, so this inside function, we must let it equal greater than 0 and solve. So for example, here it's x minus root 3, so x minus root 3 is greater than 0, so x is greater than 3. So it means that 3 to infinity is your maximal domain. So we can say dom of g is 3 to infinity. Easy. What about your range of g? Well, your range of g, well, it's easy to find the range. It's just, if you can, it's easy to draw this. So we know it's going to have a root 3, so at this point, so x equals 3, it will have an asymptote, and it's going to be looking like this. That plus 2 does not do anything too much, so it's going to look like this, and the range is just all reals. That's that. So the next one, find the equation with a tangent to the graph of g at 4 over 2, so 4 on 2, okay, easy. So we can say that what is its gradient? So what's g dash of x? It's 1 over x minus 3. Is that right? So inside function derivative is just 1. And okay, yep. And what's g dash of 4 at that point? So it's 1 over 1, so just 1. So yeah, and we already have these 2 points, so we know that we can use y minus y1 equals your gradient, and we can say x minus x1. So y minus 2 is 1, so x minus 4. Y equals x minus 4 plus 2. Y equals x 2 minus 4 negative 2. Yeah, so that's find the equation of the tangent, easy. On the axis on page 7, so here, sketch a graph of the function g, labeling any asymptotes for its equation. Also draw the tangent to the graph for the 2. Okay, so let's draw g. Now, so we know it has an asymptote at x, so here, x equals 3, so a nice asymptote we'll draw. Yep, so x equals 3. And yeah, it goes like this, but let's just say we sub in a point. For example, let's sub in 4. So we know, no, yeah, it'll be 4 on 2. So 4 over 2, 4, 2, which is over here. This is the point. There's a point. What about 5? If we sub in 5, yeah. Okay, I'm just gonna have so 5 at 5. So 5 minus 3 is 2, so log e2 plus, it's 2, it's like decimals at that point. But yeah, we just need that, and if we just draw a nice sketch, so like a nice sketch of that, like that, it goes like this, let's just say it goes like that. And we know that there will be a tangent. So we've labeled the asymptote, so I'm just going to go and label any asymptote of its equation, and draw the tangent at 4 on 2. Okay, let's do that. We know the tangent's this, x minus 2, so it will pass through -2, this point, and it will pass through this point. So drawing a nice line that passes through those points, that here is y equals x minus 2, and this over here we can say is g of x, y equals g of x. And yeah, that's that for that one. Is that it? Let's just label this as 4 on 2. Let's double check. On the axis, sketch the graph of a function, label any asymptote of its equation, and also draw a tangent. Okay, that's that. On to the next question. Question 5. Let h be this. Find the values of x such that h of x squared equals 1. So 2x plus, okay, so we're saying h of x, so we're saying square root of 2x plus 3 minus 2 squared equals 1. And we can say that 2x plus 3 minus 2 equals plus or negative 1. 2x plus 3 equals 2 plus 1. 2x plus 3 equals 2 plus a negative 1 squared. So 2x plus, okay, 2x equals 2 plus a negative squared minus 3. And that'll be x 2 plus a negative 1 squared minus 3 all over 2. So your values of x is x equals, let's try the first case with 2 plus 1, so that'll be 3 squared, so it'll be 9 minus 3, 6 over 2, 6 over 2, which is 3. And the next one is 2 minus 1, so 2 minus 1 is 1 squared, 1, 1 minus 3, negative 2, negative 1, so negative 1. All right, that's those two values. Find the domain and the rule of the inverse of h. Okay, easy. So let's first find the rule. So let y equal h of x. Interchange x and y. So that will mean x equals 2y plus 3 minus 2. So it'll be x plus 2 squared 2y plus 3, x plus 2 squared minus 3 all over 2 equals y. Is that right? Yep. And that's therefore your h inverse of x. So h inverse of x is x plus 2 squared all over 2 minus 3 on 2. Your domain is the range of h of x. So your dome of h is equal to the range of h. So what's the range of h? Well, we know it's a square root graph, which is translated, so 2x plus 3 equals 0, 2x equals negative 3, x equals negative 3 on 2. Yeah, it's translated to the left by -3 on 2, and it's been downward. So normally it's like this, so it'll be gone this way and -2. So it's pretty much like this now. It's over here, and this is -3/2 and -2. And the range is from what? It's from -2 to infinity from the graph. So yeah, -2 to infinity, -2 to infinity. So your DOM of H inverse is -2 included to infinity. Very nice. Yeah, so that's that. Jacinta tosses a coin 5 times. So okay, assuming that the coin is fair and given that Jacinta observes a head on the first 2 tosses. So she throws it 5 times, the coin, and she's already observed 2 heads on the first 2 tosses. Find the probability that she observed a total of 3 or 4 heads, or 5 heads. So 4 or 5 heads. Because we know that she's already had 2, and you remember she's thrown it 5 times, so the total is 5, and we already know she's thrown it already 2 times and it's already been heads. So the only way we get 4 the first time, like we get 4, remember, so let's think of it like this. So she's thrown it 5 times, and on the first 2 tosses she's already got the heads, and she wants another, but she wants in total 4. So we just need another 2 to make it. Okay, assuming that the coin is fair, given that she observes a head on the first 2 tosses. Find the probability that she observes a total of 4 heads. Okay, so for her to observe a total of 4 heads, for the first 4 heads, let's say we already know she's thrown it 5 times, so we already know she's already got 2 heads. So she will just need another 2 heads, like another of 2 heads. So we can say she needs another probability of x equals 2, and or, so plus 5 heads. So for her to get the 5 heads, we already know she got 2, so she needs another 3 heads. So probability of x equals 3, another 3 heads, where our x here, our x is binomially distributed. So the max is 3. We've thrown it 3 times. Well, she's thrown it 5 times, but remember, we already know that she's tossed it twice. So 5 minus 3, so there's 3 tosses that she can do. Probability of success, because remember, it's half, because she's thrown a fair coin, and we want heads. Is that right? Is this right? Assuming that the coin is fair, and given that Jacinta observes a head on the first 2 tosses. So she's thrown it 5 times. She's already observed 2 heads. Find the probability that she observes a total of 4. So to get 4, we already know she has 2, so she needs to throw another 2 to make it to 4, and also another 3 to make it to 5. So yeah, probably x equals 2 and probably x equals 3. Yeah, so that would equal 3 choose 2, probably success is half, 2, half, 1, plus 3 choose 3, half, 3, half, 0. 3 choose 2. Well, if I'm just drawing this, so it'll be 2, 3, 3, 1, 1. So 0, 1, 2, so it'll be 3, 1 over 2 to the power 3 plus 1 to the power 3. So it'll be 4, 1 squared to the power 3, which is 4, 1/8, which is a half. Is that right? So half. Hope it is. Okay. Albin suspects that the coin of Jacinta toss is actually not a fair coin, and he tosses it 18 times. Albin observes a total of 12 heads, so he observes a 12 heads from the 18 tosses. Based on this sample, find the approximate 90% confidence interval for the probability of observing a head when this coin when this coin is tossed, use the Z value 30. Okay. So your P, this is what? 12 over 18, which is 6 over 9, which is, how many 3's can so it'll be 2 on 3. That's your, so we're trying to find the confidence interval. So we know the confidence interval is P this minus Z to the square root of P this on minus P this all over N, and P proportional P plus Z square root of P this 1 minus P this all over N. That's what we're trying to find, the 90% confidence interval. So we can say so we're saying 2 over 3 minus, our Z value is 33 over 20 to the square root of P, which here is 2 on 3. 1 minus P is 1 on 3 over N. Well, he tosses it 18 times in total. So, So 2 on 3 plus 33, 20, same thing. So 2 on 3, 1 on 3, 18. Okay. That'll be 2 over 3 minus 33 on 20. Okay, let's just simplify that thing here. So it'll be 2 on 9 divided by 18, which is divided by 18, which is 1 on 18. This becomes 9, so 1 over 81. And the square root of that is just 1 on 9th. So 1 on 9th. It's such an ugly exam. 2 on 3 plus 33 on 20. 1 on 9. So 2 on 3 minus, how many 3? So 11 on 20. How many 3? So 1 on 3. Is that right? So there's 11 33s, there's also here. 2 on 3s plus 11, 20 plus 1 on, times 1 on 3. 1 on 3. So simplifying this all over all. So 2 on 3 minus 11 on 60. 2 on 3 plus 11 on 60. So that'll be, okay. So 60 times 2 on 3, 60 times 11 on 60. So here, 20. So we're saying 40 minus 11 all over 60 for this one. So what's 40 minus 11? It's, so we're saying 30 minus 1. 29. So we're saying 29 over 60. The other one is just going to be a plus. So it'll be 55 on 60. Is that right? 29, 60, this. Yeah. Is that right? I'm just not too sure if I've done the calculations right over here. Just look here. 40. So 40 plus 11, 51. Oh my God. 51 here. 51. Yeah, 51. Okay, perfect. Guys, I'm so tired. Just doing these exams is exhausting. I don't know, these questions are so different to the normal exam questions. The shaded region in the diagram below is bounded by the vertical axis. The graph of the function with the rule of f(x) and the horizontal line segment that meets the graph at x equals a, where a must be between 1 to 3 on 2, which makes sense, yeah. So a is over here, and it's between 1 and 3 on 2. And we're saying, let a on a be the area of the shaded region. Okay, show that a on a is this. Well, we can say, if we find we already know the value of a, so if we can find this line over here, if we can find the equation of this line, which is very easy, it's just f of a, which is, in this case, sine pi a. That's that equation over here. So we can say that the integral from 0 to a of the upper function, which is this over here, your sine first, so sine pi x minus sine pi a, which is a constant, dx, which is, so negative 1 over pi, this will turn to cos pi x, is that right? So, yep, so 1 over pi, okay, yeah. This is a constant, by the way, remember, so we can just put pi a times, like we'll put an x over here, from a to 0, negative 1 over pi cos pi a minus sine pi a on a minus, so if I sub in negative 1 over pi, what's cos 0? It's just 1, so put a 1 here. The other will be 0, so just that. This will be negative 1 over pi cos pi a minus a sine pi a plus 1 over pi. Is that the same? So 1 over pi minus a sine pi a. Yeah, so it looks the same. Just let me rewrite it. So 1 over pi minus 1 over pi cos a pi minus a sine a pi, which is your a on a. Okay. Yeah, 3 marks. Looks good. Determine the range of values of a on a. Range of values of a on a. Okay, well, we know that a can only be between that, and we already know the equation, so it's very easy. We just need to say, what's a on 1? So, a on 1, if I come to the equation, it's 1 pi, so 1 pi minus 1 pi cos pi is negative 1, so minus sine pi, which is 0. So it's just 2 pi, 2 over pi. And what's a on this one? 3 over 2. So 3 over 2 would be 1 over pi minus 1 over pi cos 3 pi on 2. What's cos 3 pi on 2? Drawing the graph of cosine, it is 0. So put a 0 over here. Minus 3 over 2 sine 3 pi on 2. What's sine 3 on pi on 2? So if I draw a sine graph, 3 pi on 2 is here, which is negative 1. So this over here will be just negative 1, which is 1 over pi plus 3 on 2. So it'll be 2 plus 3 pi all over 2 pi. So your values of a on a, so your values of a on a must be between 2 plus 3 pi over 2 pi over, so on 2 pi. That's where your range is. Yeah. Not a bad question, actually. They just give you the hint over here where a is between that. Yeah, so look over here. So we know that when it must be between this, and what I just did was we trying to find the values of a on a, which is, if I'm putting a on a, this must be a on 1, and this one must be a on 3 on 2, and that's what I just did. So yeah, not too bad. All right, that's done. Express in terms of a on a, for a specific value of a, the area bounded by the vertical axis, the graph of y equals this, and the horizontal axis. Okay, So this is y equals 2 sine pi x plus root 3. And if I draw this graph, if I nicely draw this graph, it's gone up, and it pretty much looks like this. And so this will be root 3 over here. And what we're trying to find is, especially in terms of for a specific value of a, the area bounded by the vertical axis. So your vertical axis, this axis, the graph of this, and the horizontal axis, which is here. So we're trying to find this area. This is the area. Okay, and this is going to be your value of a in this case. So it's just when pretty much, yeah, so we need to solve for when y equals 0. So 2 sine pi x plus root 3 must equal 0. So sine pi x is negative root 3 on 2. And we know that when it's sign negative, so C here, A, S, T. So it'll be pi x, and the base angle is pi on 3. So it must be in this over here, because we cannot use this one. If we're using that one, we'll get this value, but we just want the first. So we want it in that quadrant. So it'll be pi plus pi on 3. So pi x is 4 pi on 3. So x is 4 on 3, which is your a value, actually. Yeah, so a equals 4. That's your specific value of a. So and it says express in terms of a on a for a specific value. Okay. So we can write, like, if we were trying to find the area, it's this. We're saying, like, pretty much it's like we're going from this, from 0 to a, which is 4 on 3, of this equation, which is, take the 2 out, sine pi x plus root 3 on 2 dx. How can I express it in a on a? So that's that. If we go up to this equation, okay. If we know that a on a is this, yeah? What can't we just say in this case? Let me just copy this over here. Copy this and come bring it here. Let me just bring it over here. And I'm just going to make everything over here smaller. Let me just make this smaller and put it over here. Okay, so we have this equation over here that we're going to use as a reference for a on a. If because we know our a value is 4 on 3, let's sub it into a 4 on 3, which is 0, 4 on 3, sine pi x minus sine pi on 3. Sine pi on 3. So sine 4 over 3, so pi plus x is plus root 3 on 2 dx. Aha! Aren't these actually similar? So a, this, is similar to this. But this one is twice as much. So we can say that it's pretty much twice the area. We can say, yeah, area is pretty much twice the area of a on a. Yeah. Yeah, that's that. Yeah, perfect. So we got expressed in terms of a and a for a specific value of a. We've done that. The area bounded by the vertical. Okay. Hence, I've always find the area described in part CI. Okay, so that area. Okay. So yeah. So we just okay. Let me write the equation here. So we're saying we know it's 2 from 0, 4 on 3, sine pi x plus root 3 on 2 dx. Take take the 2 here. This will be negative 1 over pi cos pi x. Wait, so plus root 3 over 2x. 4 on 3 is 0, so it'll be 2. Negative 1 on pi cos 4 pi on 3 plus, so root 3 over 2 times 4 on 3, it's 4 root 3 on 6 minus, if I sub in a 0, on a cos, that's 1. Alright, let's simplify this. It'll be 2. So, okay, pi plus pi on 3, it'll be negative, so this will be negative pi, negative cos pi on 3. And remember, pi on 3, it'll be half, so negative half. This will become just negative half plus 4 root 3 on 6 plus 1 on pi. 2 1 over 2 pi plus 4 root 3 on 6 plus 1 on pi. And multiply that 2 by everywhere, it'll be just 1 pi plus 4 on 3 plus 2 on pi. Is that right? Yeah, so 2. And if I pull that 2 here. Okay. This simplifies to 3 pi plus 4 root 3 of this, which is 9 plus 4 root 3 pi all over 3 pi. If I done a mistake. 1 mark, and I did all of that. Was I supposed to do some other way that was quicker? Okay, if we knew that this was twice the area of that. Okay, yeah, should be that. I'm just going to make it quite small. So I'm going to change some stuff up. For example, I'll take this. Just make it smaller, put it over here. And this over here. Take it and put it over here. Your final answer is this. I hope it's right. If it's not, I'll go double check it in the solutions after. Question 8. This is the last question. Okay. A first standard die is rolled 50 times. Let W be the random variable of a binomial distribution that represents the number of times that the face with a 6 on it appears uppermost. Write down the expression of probability of W equals K, where K must be from 0 to 50. Okay, not too bad. So, we're saying we want to find the probability that W must equal to K. Well, easy. We know that there is what? We know that there is 50. Choose K. Probability of success is 1 on 6. K. Probability of success 5 on 6. 50 minus K. Write down the expression. Yeah, that's that. Yep, 50 this. Yeah, in terms of K. Show that this equals that. Okay, so what we're saying is probability of W equals K plus 1, which in this case is what? Well, it's what? 50 choose K plus 1. Probability of success is 1 over 6. K plus 1. Probability of unsuccess 5 on 6. So 50 minus K plus 1. So 50 is K minus 1. So it'd be 49 minus K. So 49 minus K. And if we divide that by probability of W equals K, this whole thing we're saying is 50, choose k, 1 on 6, k, 5 on 6, 50 minus k. Okay. Well, if you guys don't know, we know by, it should be in your textbook and in your formula sheet, this formula. To simplify, like, let's say, n choose x, something like this formula, it's pretty much n factorial over x factorial n minus x factorial, if I'm not mistaken. I hope that's right, if I've memorized that. Yeah. So using that to simplify this, like these factorials, because we can't, it's not in the actual thing, so we have to simplify those. So, okay, so we're saying, oh my god, it's actually a lot. Let me just make this less smaller so I can, okay, let me make my ink. Okay, so 50 choose k plus 1 is what? So it would be 50 factorial all over k plus 1 factorial. And 50, and we're saying then it will be 50 minus, so what's 50 minus k minus 1? So it'll be 49 minus k factorial. Okay. Alright. And times, well, we can just say 16k times 1 on 6. We can just simplify that. Next one is, yeah, even this one. We can simplify that to 49 times, no, we don't have to do that for this one, no. Because let's just use, because they have the same base, so we can say 49 minus k minus 50 minus k. So 49 minus k minus 50 plus k. These cancel out. 49 minus 50 is -1. So we're saying, but then we reciprocate it. So we can say 5 on 6 to the -1. So that's that. Yeah, that's much faster than, so yeah, let me just rub that out. We can say this 5 on 6 minus 1. Just rub that out. Okay, perfect. All over, so same thing, so 50 choose k factorial times, okay, so k factorial times 50 minus k, so 50 minus k factorial, that's multiplied by 1 over 6k times nothing, yeah, that's that. Okay, well, these ones cancel out. And wow, this is actually a lot of, okay, so this one over here, I know how to simplify it because I've done it in uni maths. There's a way which you can simplify this. So I'll just show you. Because we're saying 50, let's try to simplify this first. So we're saying 50 factorial over k plus 1 factorial 49 minus k factorial divided, so we can say just times the reciprocal, so k factorial 50 minus k factorial all over 50 factorial. Okay, these 50 factorials cancel out. Okay, there's actually a trick. So if we have, like, let's say k plus 1 factorial, this can be simplified to so the inside function, which is this k plus 1, imagine minus 1 from it, which will be k, yeah? So we'll leave, okay, so this is how there's a formula for this. So the thing here, leave it. So like k plus 1, we can say k plus 1, and the inside function in this case is k plus 1. So imagine minusing 1 from it. It's k plus 1, it would just be k factorial. So another way, this is a formula that you can use to simplify this further. It's I don't know if it's written in the Cambridge books, because I've done this in uni, but how are students supposed to do this? But wow, okay. Yeah, so that simplifies to this. So we can just say this over here can be simplified to k factorial k plus 1. Yeah. And it can be done for this other part here, which is this one over here, which is 50. What's 50 minus k factorial? Well, keep that inside function, which is what? 50 minus k. And imagine minusing 1 from it. So what's 50 minus k minus 1? 49 minus k. So it'll be 49 minus k factorial. So it's equal to that. So we can sub that in over here. So it'll be 50 minus k, 49 minus k factorial. What can we know? These cancel out now. These factorials cancel out. So it's just 50 minus k over k plus 1. So we can pretty much rub this whole thing out. Like this, just we've simplified this whole thing over here and made it easier for ourselves. Okay, so we're just saying 50 minus k all over k plus 1. Yeah. Done. So let's rub all that. Oops. Okay. Okay. This can be just put under to make it a positive. 5 on 6. Yeah. And we're saying 1 over 6 divided, so times 6 on 5. Cancel those out. It'll be 1 on 5. So this, let me just simplify this whole thing. So 1 on 5. It's such a mess. I don't. So it'll be this 1 on 5, which just can be put down. It will just be 5. Yeah. I just rubbed my whole thing. Like I've done the whole thing. I've just rubbed it all because I can't fit it. But pretty much that's how you would do it. In other words, yeah, it is. Yeah, pretty much it's a mess. That's how you would do it. That was all these working out. Look, I'm not gonna put the working out. I hope you guys understood. I'll be honest, it's a stupid question. I really find this a whole lot of rubbish. It's a question for 2 marks, and I don't know if students would know how to do the other factorial, like the factorial formulas for that, because it has not been used like in any past exams. I've just currently done it at uni, so that's how I knew how to do it. But yeah, that's stupid. Next question. Hence or otherwise find the value of k for which the probability of w equals k is the greatest. Yep, and it's the last question. Okay, so we want the probability of, when is probability of w equals k is greatest? Okay, so imagine drawing this one. I'm just going to change it back to the 4. Okay, imagine drawing a binomial distribution. Okay, that to say this is in this case probability of w, and this is w, and we want, like, let's say this is k here and it's the greatest. And remember, binomial is pretty much like this, like it's just points and they are discrete numbers. But in this case it would just look like, yeah, like a nice normal distribution. Just, yeah, think of it like that. Where it occurs, the highest probability, so your highest, the greatest, it's pretty much at its mean in this case. So we can say the expected w of w is what? It's n times p, which is, in this case, it was 50 times p, which is 1 on 6. So 50 on 6, which is 25 on 3. 25 on 3. What is that? 25 on 3. It's between 7. So 25 to 3. It's between 7 to 9. So yeah, it's around 8. Pretty much, it's around 8. Is that right? So k would be 8. Remember, it's this value, but remember, it has to be discrete. It cannot be a fraction, so that's why I'm saying it has to be. It's pretty much between a. K equals a. I don't know if that's right. So let's try another way. Actually, let's try another way to do this. There's more ways you can. Okay, what else do we know? If we would have just double checked the answer, because I'm not too sure if that's right. Well, looking at this graph over here, imagine that k plus 1 is over here. What do we know? Well, we know that the probability of k, probably w equals k, is greater. Yes, it's greater than the probability of w equals k plus 1. That's true. That's a true statement. And we know that the probability of w equals k is over here. Remember? It's this one over here, 5k plus 1. So what's 5k plus 5, just expanding it, greater than the top of it, which is k plus 1, 50 minus k. Yes. That'll be 6k greater than 45. K is greater than 45 over 6. What's that? 45 over 6. So 9 times 6, 54. Yeah, so it's between, k must be greater than that. So it's pretty much, k is equal to 8 for this one too. This is approximately nearly 8. Yeah, so k, that's another way you can do it. So k must equal probably 8 is where the probability of, this is the greatest. That's another way to do it. Is there another way? Yeah, those are the two ways I would do this question. Not too sure if they are right. But it looks right for both of them, Look, I'll be honest, this exam is just rubbish, to be honest. It's a rubbish exam. I've never seen an exam like this. I don't think, it's actually a quite hard exam. Like, I'm kind of struggling if, I'm gonna go check the answers after this, but, like, the probability question, like, these are all nice questions over here. Quite good. Nice. These are all good questions. But this one was all right too. No, but this question over here, where was it? This probability question over here is quite totally different if you really look at it. Like, you really had to understand the question. It wasn't. This one over here, not bad. Okay, not bad. This was, not bad. This one over here, no. I don't know how students will. Look, the question 1, like question 8, part A is good. It's normal. Like, students should know how to do that. But part B, it's stupid. I mean, doing for 2 marks. Look, if I was examined, I would have put 4 marks for this question. Now, first of all, I would never put a question like this because, again, it's too long. Like, and a lot of students, remember, you don't have a formula sheet. So how are you supposed to memorize? Like, if it was in exam 2, it makes sense. You would put it on your formula sheet or your, But for this, it's stupid because, it's exam 1. You don't have a formula sheet. You just have to use the VCAR one. And, it doesn't have anything that can help you. That was I hope you guys enjoyed this video. Please make sure to like and subscribe. And, if you want more videos, please, go subscribe to my channel and, share it with your friends. I'll go through more exams. I do tutor VCE Physics, Specialist, Method, and Chemistry. I tutor all of these subjects. If you guys want to be tutored, please email me down below, or their link is right over here. You can email me through this email, and we can discuss. Perfect, guys. I hope you guys enjoyed this video and have a good day. Take care. Bye-bye.